I'm Anil Kumar. In this particular video, I'll discuss 3 questions. These questions have been provided by my student Christopher. Let me thank him first and all the subscribers for really posting excellent questions and participating actively on my YouTube channel. All the 3 questions which I am discussing will have a common thing, and that is discussing about the bearing angle, right? So that is kind of critical to understand. Question number 1 here is, a surf sailor at Tofino, west coast of Vancouver Islands, sails 200 meters on a bearing of 0-20 degrees. Whenever we write bearing angles, we should write in 3 digits. Right, so the statement here is, a surf sailor at Tofino, west coast of Vancouver Islands, sails 200 meters on a bearing of 20 degrees, changes direction to north 40 degrees west, sails 100 meters and stops. How far from the original position should a friend sail to meet him? And part B is, in what direction should the friend sail? So let us make a diagram here, which is kind of critical to understand all such questions. Now, when we say bearing of 20 degrees, it means from north, right? So we are always measuring angles north going clockwise. 20 degrees clockwise, you can think like this. So from here 20 degrees. And the length of the arm will actually give us the distance, which is 200 in this particular case. So we are going to say that this is 200. Okay. Now the angle here is 20 degrees. Now at this point, the sailor changes direction. So I'm just drawing my coordinate plane once again here, so that I could show the next direction, which is changes direction to north 40 degrees west. That means from north 40 degrees this side. So we'll go kind of like this, right? So that is from north 40 degrees west. So this angle becomes 40 degrees now for us. Is that clear? And stops. So the first distance covered is 200 meters. And this time this is 300 meters. And then stops, let us say. So the final position is right there. We'll just join this final position with the origin, right? Let's say that is the origin. Let me label this diagram. Let's say O, A, and B. So the question is, how far from the origin position should a friend sail to meet him? That means we need to find the distance OB. Now given these angles, we can find the angle at A. 40 degrees means with 90 that becomes 50 degrees for us, right? Now this is 20. Now that means what? Well, that means that this angle is 90 minus 20, which is 70 degrees, and alternate angles 70 degrees, correct? So 50 plus 70 is 120 degrees, correct? So let me write this angle here as 120 degrees, correct? So we know 2 sides and included angle is a case of side angle side, and therefore we can apply cosine law and find OB. So OB square is equal to sum of these 2 squares, which is 300 square plus 200 square, minus 2 times 300 times 200 times cosine of the angle in between. So I'm direct application of formula, right? Cos of 120 degrees. That is what it is. So let's calculate this value. It is 300 square plus 200 square minus 2 times 300 times 200 times cos of 120 is equal to 190,000. 190,000, right. So if I have to find what OB is, I will do square root of this, right? So let me do square root of our answer and see what it gives. It gives us a value which is 435.8, 435.8, which we can approximate as 436. The units are meters. Perfect. So that is how you get part A, which is how far from the original position should a friend sail. So friend should sail 436 meters. Now the second part is to find the angle, right? So part B, to find the angle, we have to use the sine law, right? So now we know this distance is, we'll use 435.8, right? So you could use 436, doesn't matter. 436, right? Now since we need to find the angle, it's better to give this angle from the north how much. So we'll find angle at O, AOB. So we can write this as sine of angle O over side opposite is 300 is equal to sine of 120 degrees divided by 436. I'm rounding this answer, is it okay? So we get the angle O as sine of angle O is equals to 300 over 436 times sine of 120 degrees. So the sine value of the angle is 300 divided by 436 times sine of 120, which is equal to 0.5958. So the angle O is equal to sine inverse of 0.5958, which is, let's figure it out. So shift sine inverse of our answer is equal to 36.57. 36.57. So that becomes the angle, right? Now, clearly, that is the whole angle, including 20, right? So from the north, it could be written as 36. Let's call this as approximately 37 degrees. Okay. So we are approximating this also as 37 degrees. Now the angle which we need to write is from the north. So from the north, the bearing angle could be written as, or we could even write this as the angle is from the north. This angle is 37 minus 20, which is 17, right? 17 degrees west, right? So that is the bearing angle. So from north, 17 degrees west is the angle from O, right? This is one way of writing. The other way could be, we could write this angle from as a bearing angle. Is it okay? As a bearing angle. So that angle really is, let me write it down. It is 37 minus 20 degrees, which is 17 degrees. So that is 17, correct? So it could be written as 360 minus 17, 343, right? So we can say bearing angle of 343 degrees, 343 degrees. That's an alternate way. So that could be the answer for part B. So the answer is friend should sail at a bearing of 343 degrees. We are rounding to whole numbers, right? So that is how it can be done. Now let us see the next question based on bearing angles. It is two forest fire towers A and B are 20.3 kilometers apart. The bearing from A to B is north 70 degrees east. The ranger in each tower observes a fire and radius the fire's bearing from the tower. The bearing from tower A is north 25 degrees east. From tower B, the bearing is north 15 degrees west. How far is the fire from each tower? You can actually pause the video now, answer the question, and then look into my suggestions. Now let us see how to solve another question based on bearing angle. Question number 2 here is, two forest fire towers A and B are 20.3 kilometers apart. The bearing from A to B is north 70 degrees east. So let us try to sketch this diagram, right? Sketching is a very important part of solving all these questions. So the first one, let us say A is at the origin, right? Then it becomes easier for us to graph. So it says A and B are 20.3 kilometers apart. The bearing from A to B is from north 70 degrees east, right? So you could also read this as 70 degrees east of north, right? So 70 degrees east of north will be like this. That's the point. And the distance is 20.3 kilometers. And this angle here is 70 degrees. This is north for us, right? And this is east. So 70 degrees east from north, let's say the point is B. Perfect. The ranger in each tower observes a fire and radius the fire's bearing from the tower. The bearing from A is 25 degrees east of north. So for the fire, it is 25 degrees east of north. So let us say that is 25 degrees east of north. Somewhere like this. Where this angle here is 25 degrees east of north. Now from tower B, the bearing is 15 degrees west of north. How do we sketch this? So let's temporarily make our coordinate system here, and then we are going to sketch it 15 degrees west of north. So that means something like this, and it will intersect at the fire, right? So let's say kind of like this. Okay. Let's say this point is the fire point. And the angle is 15 degrees. Does it make sense to you, right? So I hope the diagram, the first part, is clear. You actually get half the marks at this stage itself. You need to find the angles, okay? So 15 degrees means that angle, 90 minus 15, let's calculate. Use calculator. 90 minus 15 is equal to 75. So this is 75 degrees. And now when we say that is 70, we know this angle is 30 degrees and alternate angle should be 30 degrees. Is that clear? So we'll add 30 to it. So we get 105 degrees. Correct? So this angle here is equal to, let me say this angle here is equal to 105 degrees. Since we know this is 105 degrees, we can now apply the cosine law, two sides and an angle, and find what AF is. Correct? So we get AF as how far is the fire from each tower. Let us find this angle also. which is the angle which AF makes with AB. So 25 degrees take away from 70. So let's do it. 70 minus 25. 70 minus 25 equals to 45. So this angle here is 45 degrees. So what we know here is almost all the angles. We can get the third angle also. Sum of these angles is 180. So we'll do 180 minus 45 minus 105, and that gives us 30 degrees. So all three angles are known with one side. We can apply the sine law. So we can say that AF divided by the angle opposite to AF, which is 105, sine of 105 degrees, is equal to, we know this constant, which is 20.3 over sine 30 degrees, which should also be equal to BF. So how far is phi from B? Divide by sine of 45 degrees. Do you see that? So from here we get both AF and BF. So we can write what AF is. Distance of phi from tower A is sine of 105 degrees divided by sine of 30 degrees times 20.3. You can actually calculate this ratio first and then, very easy to do, right? So we could also do that. We'll do 20.3 divided by sine of 30, and that gives you in decimals 40.6. So this ratio is 40.6. So let me write this as 40.6 for easy calculations. So basically we are writing this ratio as 40.6. So we know 20.3 over 30 is 40.6. So we're going to multiply this by sine 105, right? So we do this times sine of 105 equals to 39.2. So we get this as 39.2. To find BF, we can write BF as 40.6 times sine of 45 degrees, right? So we get 40.6 times sine of 45 degrees, which is equal to 28.7. Okay, so that becomes the distance. Since that was given in one decimal place, we are maintaining one decimal place in kilometers. Okay, so that is how you can get your answer. So the answer is distance from A, which is 39.2 kilometers, and distance from B of the fire is 28.7 kilometers, right? So I hope that is absolutely clear, right? Let's move on. We have one more question here based on bearing angle, and this time we'll take up velocities as an application. Question number 3 is, an airplane is flying at an airspeed of 500 kilometers per hour on a bearing of 40 degrees. 150 kilometers per hour wind is blowing from a bearing of 120 degrees. Determine the ground velocity of the airplane and the direction of the flight. Now, I'd like you to pause the video, answer this question, and then look into my suggestions. Now, in this particular example, we'll understand how to sketch clearly the situation where bearing angles are involved and then solve using sine and cosine law. Question number 3 again here is, an airplane is flying at a speed of 500 kilometers per hour on a bearing of 40 degrees. That means we have something like this. Bearing of 40 degrees means from north. So this is north for us. Let's say that is 40 degrees. And the length of the arm which I'm going to draw will represent the speed, which is 500 kilometers per hour, right? So let that be 500 kilometers, right? So this is 40 degrees from the north, and the distance here is 500. 150 kilometer per hour wind is blowing from the bearing of 120. So from the bearing of 120 means this is 90, right? So 30 more. So kind of like this, 30 more, right? So that becomes the direction for the wind from the bearing of 120. So that is the direction. I hope you get it, right? Now, so this angle becomes 90 plus 30. So this becomes 30 degrees. Total is 120 from north, correct? Determine the ground velocity of the airplane and the direction of the flight. Now, if the plane was supposed to go in this direction and the wind is blowing in that direction, so basically it is going to shift the course of the plane. Do you see that? So that is going to be the effect on it. Now that is 150 kilometers. So imagine that this length is 150. So what we have done is we have shown this in a scale 500 to 150. So clearly the resultant will be from origin to this point, right? So that becomes the resultant for us. So the plane will actually go in that direction. We need to determine ground velocity, that means this net velocity, or the resultant velocity. Let's call this as R. And the direction of the flight, so we'll find this angle also. So that is the whole idea. I hope you understand this. You can now pause the video, answer this question, and then look into my suggestions, right? Okay. So as we did in previous example, I'm again sketching a coordinate plane there to figure out the angles. Now, the angle here is 40, so this is 50 degrees, and that 50 alternate angle is 50 here. Perfect. So we have 50 here. Now 30 degrees with the horizontal. Do you see this 30 degrees with the horizontal? So that really means this is also 30, right? So that angle is 30 degrees. So the total angle is 80 degrees. So let me call this 0, A and B as the position. So we know that the angle at A, which is 0 OAB, is equals to 30 degrees plus 50 degrees, which is 80 degrees. Now the angle, we are looking into the triangle AOB, right? So in triangle AOB. So the other angle, which is O, should be how much? Now, which is not very clear to us. But knowing one angle and two sides, we can find what OB is. So let's use cosine law and find OB. So OB square we'll find first, which is 500 square plus 150 square minus 2 times, square times 2 times 500 times 150 times cos of angle, which is 80 degrees. Okay, let's figure this out. 500 square plus 150 square minus 2 times 500 times 150 times cos of 150, 80 degrees, okay, is equal to a number which is 246,452.7. So that is what this is equal to. But if I need OB, I will square root this number, right? So let me square root this number. So we do square root of our answer, and that is equal to 496.4. You check your calculations. My calculations could be, incorrect. So, but I hope the method is clear, right? Okay. So what we get here is 496.4. Okay. Now, OB is known to us. So we know that the ground velocity of the airplane is 496.4. Since 150 is actually kilometers per hour, we just taken a situation where time is 1 hour. So the distance represents the velocity. Now let's find the angle. To find the angle, we have to use sine law. So we can say sine of angle O, which is angle BOA, that's another way of writing this, divided by the side opposite, which is 150, is equal to OB, which we just calculated, and the angle is 80. So we write this as sine of 80 degrees divided by 496.4. Cross multiply. So we get sine of angle BOA equals to 150 over 496.4 times sine of 80 degrees, which is 150 divided by 496.4 times sine of 80 degrees is equal to 0.2975. So we get the angle BOA equals to sine inverse of 0.2975. So we do sine inverse of the answer, and that gives us 17.31. So the angle which we get here, this angle, is 17.31. Okay, so that becomes 17.31. Since this angle is 17.31, what is the bearing for OB? So the bearing angle is 40 minus 17.31, right? 40 minus 17.31. So let's do this. 40 minus 17.31, which in decimals is 22.7. So that is a bearing angle. So this angle here is 22.7 degrees from north, right? So we have our answer, that is the ground velocity is 496.4 kilometers per hour at bearing of, we can write this as 23, right? 023 degrees, right? Approximately. So rounding it to one whole number, it is 0.23 degrees. So that is how you could actually solve this question. So I hope with the help of these three examples, the concept of bearing angle and its related application questions is absolutely clear. Feel free to write your comments and share your views. If you like and subscribe my videos, that'd be great. Thanks for watching and all the best.